understand what I'm trying to say here?
Well,
fixated on the idea that the Lorentz transformation is a substitute for a Galilean transformation. And then he says that's wrong because there's this extra term, this x dx over c squared term in the time transformation. He says, nobody understands what that means. So they say, okay. So he throws it out. Okay.
yeah.
But the Lorentz transformation, I don't think has anything to do with the Galilean transformation at all. It's not a substitute. Now, what Stephen thinks is, based on Solari, that the Solari transformation is a substitute for the Galilean transformation. Okay, so what he's saying is the LT, and when he talks about the LT, he talks about Einstein LT, not the LT with the preferred frame. Okay, he says that's wrong, so I'm going to throw that out. Then I got to find something that substitutes for it under the assumption that the Galilean transformation is wrong, and I need a substitute for the Galilean transformation, and that's what he calls the STs. But they don't really. Nick has pointed out, and I agree with Nick, that it just confuses things more.
Well, I think Roger made one line, I think in his last email, just the last line, I think was worthwhile. He said, how do you derive them? I mean, it appears that he just didn't like that extra Vx over c squared term, and he just takes it out. But he keeps the other...
Let me sort of go into that. I looked into this, and if you want to go into how the STs are derived, the reason why you don't hear about that is because it's a big, long rigmarole. You have to go into all this. If you go look at the papers, it's very complicated mathematics, and it goes into this business of what an inertial transformation is. Stephen sort of invented this idea of calling the transformations STs or Solari transformations. Solari calls them inertial transformations, so that's a bit of a confusion. But anyway, Solari goes through this whole big, long mathematical, I mean, it's a lot, and it's difficult to follow. I think that's one of the main reasons why people have really paid much attention to it. It's very difficult to understand what he's doing. It's very difficult to follow his reasoning. And then he comes up with these transformations at the end, which don't seem to me to be right. But he gets the Einstein transformation at time at the end, which is t prime equals t divided by beta, okay, which is the same thing that Einstein got in 1905. So where's the innovation, you might say.
Yeah, I'm partly responsible for pushing him into giving this, because the first two talks were his so-called establishment that the LTs didn't accord with a number of experiments, but the STs did. But those 10 experiments he gave, the Galilean transformations would comply with, would explain it. So I said, well, can you give us some experiments where you claim the STs would be satisfactory, but the GTs wouldn't? So hence the attempt yesterday at the talk. Now, I don't know if he's totally done so. In fact, I said at the end, I said, well, I consider the LTs just really a fudge, but at least they give the correct answer in transforming between electric and magnetic fields in relative motion.
Yes, let me just point out, you got the same problem. If you use the LTs to go from the electric field to transform the electric into magnetic fields, you can't go back and get the original. You have the same paradoxes that you have in curiously, nobody's really pointed out that there's the paradox also applies to the transformation of electric field. So in other words, if you transform if you have a magnetic field in the rest frame and you transfer to the moving frame, you get an electric field and a magnetic field, right? But you can't go back and get a magnetic field when you come back, when you transform back. Do you understand what I'm saying? It's the same paradox that you get with when you try to transform time and space from the moving frame back to the rest frame.
The reciprocity
Paradox.
business, yeah.
So there, you still have the same paradox. It's my point. In other words, the transformations required to be symmetrical means you can't get the right answer, even with electric and magnetic fields. So you get the right answer when you transform from the moving frame to the rest frame or whatever, when you do the one-way transformation. But you don't get the right answer when you try to transform back.
Okay, well, that's an interesting
point. Would it be
point.
acceptable to say that, given Harry's point, that the physicality of the LTs is questionable?
Well, yes, that's another way of making a point I was going to, Jim. I said to him that I didn't. To me, T dash equals T, T prime equals T, and I don't need to put this factor in because that's a physical effect which experiments show happens with atomic clocks. But by the way, maybe Nick isn't here, is he? I might just give you a very, very. I won't go into details, but just a very, very brief heads up, you gentlemen. Nick sent me quite a snorter actually about having the talk yesterday, and we shouldn't have him again.
Nick didn't show up, and I guess he figured that if he did, it would create a. He sent me an email, and I replied to it. He thinks that what Stephen says is just ridiculous, and he's dead set. He's opposed to anybody paying any attention to anything that Stephen says. And I'm somewhat sympathetic to that view.
Well, I see where you're coming from, but I sent Nick a fairly robust 3-liner or 4-liner, just saying that I wasn't prepared to act in that way as a moderator. I would not sanction any subject or any particular speaker. And if the CNPS wanted such a moderator, they'd have to look elsewhere. So I told him I wasn't prepared to do that at all. But then I said I welcome robust criticism of any particular subject by people attending the lecture and posing questions.
I've had dealings with Stephen in the past, and he's kind of a hard-headed guy. So I didn't really want to say anything. So that's kind of. I pointed out to him. I told Stephen to go look at these papers that I've written, and he did, and he came back with a bunch of irrelevant criticism. Well, you said this is wrong, and this is wrong, and this is wrong. He completely didn't want to. He didn't want to really understand my point that I was trying to make. He just looked at what I had written and said, that's wrong, I don't accept that. And that was the end of that. And so.
Yeah, and to a certain extent, he didn't totally answer some of the points made by others, and indeed by me. And I didn't push it. I didn't say, look, no, that's not an answer, Stephen, go further. Because I was quite happy that he would express his position. And we would be able to deliberate on it at a later stage. There's very little to be got by just going back and forth. If you're not getting an answer to your question in the short time we had available.
Yeah, but you notice that he does acknowledge that the ST isn't any different than what Einstein was in 1905, and which I think is a big step forward.
Well, to me, the red rag was when he said that the two-way speed of light is constant. I mean, that's basically the Einsteinian position, which so-called explained the MMX.
I know, and that part confuses me. And to be honest with you, you're really okay. I don't know
he's halfway to there. He says the one-way speed of light is variable. We all agree with that. It's c plus or minus v. He accepts that. But the two-way speed of light is magically constant.
Yeah, the problem that I have is that there's a lot of terminology that people use that means different things to different people. I mean, I don't know how to solve that. Stephen has is in his own world, and he talks about the LTs. This is what annoys Nick. He says the LTs. Says the LTs, but he doesn't. He means the Einstein LTs. When he says the LTs are wrong, he means the Einstein LTs. And Nick gets upset because he says that, well, you're throwing out all the LTs, and you're throwing out the baby with the bathwater. So his terminology is kind of confusing. I don't know what to say.
Well, I mean, Nick has invested very much in the Lorentz ether theory, and it is based on using these transformations between frames. And
right.
Therefore, he obviously is quite concerned when that is attacked.
Right. If most people, I've tried to get people to read the papers that I've written, and they're at the GSJ.
Yeah.
And I explain all this. I went through it all. This is all 20 years old. I've been telling people about this for 20 years, and it just doesn't go anywhere. People don't understand this idea of this changing the scale. The Lorentz transforms is not a replacement for the Galilean transform. It tells you how the scale changes. The scale is not the same in the moving frame as in the rest frame. Okay, so in the moving frame, the time scale is different. Time is dilated in the moving frame. Okay, it's not, and so what you do is when you substitute the scale changes back into the Galilean transform, then it works. Okay, but it doesn't work unless you change the scale. You have to change the scale of time and space in order for the Galilean transform to work in the moving frame. But what people do is they say, oh, I'm going to use the LT as if that's the Galilean transform. That's what Stephen says. And then he's got this Vx over c squared term in the time transformation and says, well, I can't make any sense out of that, so I'm going to throw that away, and I'm going to adopt the Solari transform. Does that make sense to you? What it's about?
Yes. I mean, I think conventionally they don't make these scale changes, and therefore they don't get the simple velocity addition formula. They get this complex one.
Well, if you read my paper, you'll see that the velocity addition formula falls out from the scale changes.
Yeah, I saw that. That was 7.3 or something. I saw that, yeah. But they don't do that.
That means that all you're really doing is changing the scale. Okay, so what Einstein does, he assumes that the scale of measurement is the same in the moving frame as in the rest frame. And then he says, oh, well, wait a minute, time is different in the moving frame than in the rest frame, where it's different. And so he says, well, time has changed. Time didn't change, just the scale of measurement of time changed. But people don't understand this. I've been explaining this to people for years.
And the other point is, unless I have some evidence to the contrary from Stephan, he seems, as you say, Harry, to have thrown out that term Vx over c squared because it didn't look attractive. I'd like to see the derivation of that.
It doesn't work in the Lorentz. You can't make it. The mistake is thinking that the LT is an equivalence to the GT at high velocities. That's not what it does. It changes the scale of measurement in the moving frame. Okay. Tells you how to change the scale. Tells you how the time scale or the basis of measurement is changed in the moving frame as opposed to the rest frame. But physicists assume that the measurement scales are the same, and they're not. So when you take a clock that's been adjusted in the rest frame and you put it in a GPS satellite and have it go around the Earth, it runs at a different rate. Okay, that means that the scale is different in orbit than it is on the ground. And so what they do is they say, oh, let's tweak the clock let's tweak the clock in the satellite so that when it's in orbit, it will run at the same rate as clocks on the Earth. But they don't, there's nothing in the theory of Einstein that says you can do that. So they're making an assumption about changing the scale, okay, without realizing they changed the scale of the clock.
Could it be as simple as the clocks are differently charged than each
You're
other?
looking for a physical explanation.
Mm-hmm.
It's just a question of the measurement, the measurement scale, like you have a ruler. Your inches on the ruler are not the same length in orbit as they are on the Earth.
Well, that may be due to charge.
No, it's got nothing to do with that.
Okay, well, you put a clock in an airplane and fly it. That aircraft is going to gain charge.
You're looking for a physical explanation. We're just talking about how the mathematics works.
Right. And the mathematics might not work because the physical explanation is not being taken into account.
I just said that. I just explained that for the last 10, 15 minutes.
Right.
But by the way, he seems to say that the ST are a direct substitute for the GT.
That's the whole point. He wants to say that the STs are the substitute for the GT, that the Lorentz is not.
Right.
So the Lorentz transformation, he thinks that the Lorentz transformation is a substitute for the GT, but they're not. This is a mistake that physics books have been perpetuating for years.
Yeah, not a correct substitute, he says.
But if you take the time, so what in Einstein, what he does in his 1905 paper is he calculates the change in the clock, how the clock will change, okay, and then says, okay, so time has changed. Now time is dilated, length is contracted. Those are not consistent with each other, but anyway. And then, so what you're supposed to do is you're supposed to change, when you're in the moving frame, you go, oh, clocks are slow in the moving frame. And that's because the scale of measurement is changed in the moving frame. If you account for the change in the scale of measurement, time isn't different in the moving frame. It's just the way it's measured.
Okay. But also, the tests that he talked about, they seem to be basically due to including this time dilation factor, let's say. And he says, oh, well, look, with relativistic beaming, you get this result, and without the gamma factor, you get the slightly less. And the experiment shows the other one to be correct, and so on. So it seems to be all based on this so-called time dilation factor. Now, I would have a question about all those experiments. I don't know if the relativistic beaming, 40 degrees rather than 30 degrees is actually correct. I haven't seen that. And also, well, it's partly coming back to what Rick is going into, that the contention that there's actually clock retardation because of physical effects. And if they're taken into account, well, you've got the same thing.
Well,
you don't need the fancy math if it's a physical effect.
The math explains the physical effect. That's the point.
Right. Well, it would have to be a different math than
Einstein
what's
says
presented
that
now,
time
right?
changes. Now, let me go over it again. Einstein says that time space changes, dilates, becomes a moment in, 2 moments in time are expanded relative to the same 2 moments in time relative to the rest frame. Okay. He says that time changed. He says that space changes. Okay. But that's not what the Lorentz transformations are telling you. What they're telling you is that the scale of measurement is changed. And if you account for the change in measurement scale when you do the measurements in the rest frame, and you account for the fact that the scale is different, then it turns out the time is the same in both frames and distance is the same in both frames. Only when you fail to realize that it's the scale of the measurement that's changed and you need to correct for that, do you get this time dilates and space contracts.
Yeah, you could replace the word scale with charge just as easily, and replacing, changing the charge of a clock.
Please don't use the word charge. That charge is an ill-defined concept. That's one of the big problems with using the word, as David DeHilster has pointed out. Okay, it's you can't use the same scale of measurement in the moving frame and the rest frame. That's the whole point of it. Einstein says that when I put a clock and I move the clock and it's moving at a high velocity, time is dilated in that frame, or the time in the rest frame as it appears to the moving frame is dilated, depending upon what interpretation of this or you want. That's not what's happening. What's happening is that you need to have a different scale for measuring things in the moving frame than you have in the rest frame. And when you use a different scale of measurement, you get the same thing. So in the case of the twin paradox, what happens, and I explain this in my papers, the clock in the traveling twin is running slow, okay? His clock is running slow because he's going fast. If you speed up that clock, like they do in GPS, to compensate for the fact that the clock is running slow relative to the clock on the Earth, he's aging at the same rate as the twin on the Earth is aging, and you have no twin paradox.
Agreed.
It's all about the fact that Einstein just makes the assumption that a meter is the same in the moving frame as it is in the rest frame. And you can't make that assumption. That's not true. Okay.
Well, I don't like using Einstein's work anyway, because it's all in the head. It's all theory. It's not reality as far as I'm concerned.
Well, that's a criticism of all of modern physics.
Well, physics.
You're absolutely right.
No, not really. I mean, there are a lot of things that he got right, and there's a lot of things that he got wrong.
Yes, but modern physics went through this transition when, in the 19th century, when they adopted the idea of kind of following along with Maxwell, that the mathematics leads the way. So we create a theory by mathematics, and then we try to demonstrate that experiments prove the mathematics.
Right.
And so what happened was instead of people doing physics like Faraday, okay, who actually did an experiment and then tried to figure out what was happening based on...
And then work out the math.
They reversed that and said, okay, we've got this mathematics, and the mathematics is correct. All we have to do is find an experiment that proves it.
Yeah.
And so everything now is theoretical.
Yeah, I know.
And if you want, I can talk about this. I was going to talk about this in my radio astronomy talk. The bottom line is black holes have to exist because the mathematics says so.
Yep.
And so they look out in outer space and they say a strange thing that they can't explain. They say, well, that must be a black hole.
What are all the filaments at the center of our Sagittarius? What are all those filaments that we see in there? That's not black holes. That's electricity going in a. We're looking inside the plasmoid of the central galaxy, and black holes aren't supposed to work like that.
My goodness. Let me remind you that satellites flew through the plasma, and nobody took into account this effect. Everybody knows, but one more time, pollution. I don't know about plasma. I will use vacuum and all this comparison of his theoretical conclusions with existing test results, because there is no consideration of plasma around the Earth.
I understand
this
that.
This is a physics.
I
As for
understand,
the
and
mathematics, maybe correct, maybe not. He proved, and all the time he insisted, 5 more experiments I explained directly. But forget about this plasma, who cares?
well, I maintain that plasma is what's bending the light around objects in space, and Einstein says it's gravity. It's a plasma sheath that's contained around every object in space.
Correct you. Like you can move your beam declining only if you have your gradient of index of refraction. Yes, if plasma is not homogeneous and there are some changes in the distribution of plasma, there is some gradient of it, then only then you can talk about the inclination of beam. Sorry. Optics means index of refraction and gradient of index of refraction. Then you can move your beam. And it's exactly what is going on around the sun. I don't know, man. I'm absolutely agree with Harry. We are talking about mathematics and physics much more interesting. I mean, don't throw away baby with the bath water. This is a very good words. I like it very much.
Yeah, I think we all feel that way. I mean, I love dealing with mathematics. You know, it's second nature to me. But I totally agree with you. The mathematics must come later. It must be the handmaiden of the physics.
Secondary.
Yeah, secondary.
And in your formula, you should take not speed of light in vacuum. Please, speed of electromagnetic waves inside of the plasma, and then do your mathematics. I don't like. No, I do like it.
But space isn't a perfect
physics,
vacuum.
yeah, physics. There is no perfect vacuum. There is no. Everybody knows right now. There is intergalactic plasma, and there is a plasma around the Earth. This is additionally fact, and nobody took care about it, guys. That's why I do like mathematics. I do like logic of mathematics. But when you started to compare apple to apple, please take into account that there is a plasma around the Earth.
One of the points I wanted to make, I was working on a presentation for next Saturday, and which was radio astronomy. And I was going to run by the preliminary today. I don't know if people are interested in hearing about that or not. We sort of used up most of the time already for the first.
2 more sessions. Yes, I'm absolutely agree with you. I want to know about radio astronomy.
Let me just ask this question, Vladimir. What was your reaction to what Stephen said? What are your thoughts about Stephen's presentation? I'm going to tell you what my conclusion was. I was confused. That's my one word description.
I was confused. He didn't tell the story. And what is important? He talked and talked and talked so fast, so quickly, so... I couldn't understand him. I'm so sorry, man. I'm not expert in your business. I did read all these papers. I don't know the history of these equations. But what is important, he didn't show the difference between him and some other approaches. Like you done today. Your talk to me much more important than his talk. And always what he talked only insisted, only I can explain these five experiments. You know, to throw away somebody from his equations, and then to say that there is a coincidence. Coincidence, it's not equation, it's not equal, it's a coincidence he insisted on. This is my point.
What about you, Jim? What are your thoughts?
I just wonder about the physicality of the LT in the first place. I've been reading a few articles about the Lorentz transform, and I'm struck by the fact that there is no real world examples of its actual usefulness in engineering or in any product or technology that is even mentioned. So apparently, so that's a big question that I have. Where is this actually used in the real world?
Well, GPS, you asked that before.
But I thought
GPS
that
without plasma
Ron
is not a
Hatch's work.
GPS.
I thought that Ron Hatch's work, with the GPS, according to at least what Nick has presented to us repeatedly, excludes
Well,
that.
again, we're back to the terminology issue. What does one mean by Lorentz transformation? Do you mean the Einstein-Lorentz transformations, or do you mean the Lorentz transformations?
Well, in either one, what is really the physicality there? Can you show me examples where these transformations have any real effect? Does Elon Musk use them to put rockets into space?
They're used in particle accelerators. The particle accelerator people would say we can't design a particle accelerator without these Lorentz transformations. That would be their comment. So
Okay.
we have particle accelerators, and that would be. So you're talking about practical, useful things.
Well, let's take particle
They do
accelerators.
work. They do work
They're
when you're
using an
transforming
electric
electric to
field
magnetic
to
field.
accelerate
Correct.
electrons, okay, or charged particles. They're using electric fields. Where does a Lorentz transform come in there?
I'm not sure I understand your question, John.
Well,
Ian
you're
was
saying
talking. We got only a
said
few
that they're
minutes left.
using LTs in the design of particle accelerators, and I'm just asking where is that use shown? As far as I know, you created an electric field, and you can accelerate an electron. You use some magnets, and you can guide that electron. Where is any LT involved in the design of the Large Hadron Collider, for example?
Well, that's not an area in which I have any expertise, so I can't really answer that other than to say.
Well, but you said that LTs are used in the design of it.
No, what I said was they claim that they are.
Okay.
Well, wouldn't the bigger question be why do the Lorentz transformations work better with satellites than Newton's gravitational equations? That's a bigger question for me.
Well, they don't.
Where do they work better with satellites?
I don't think they do. No, they don't. It's too
Yeah, that's my point.
Yeah.
In other words, all of this talk about LT, I'm trying to find some real world application or relevance of it.
Yeah, but if you're working in electric and magnetic fields and transforming from one to the other and looking at velocities of particles and so on, they do work. They seem to be the correct answer. And this is a very hard thing for a person like me to say who doesn't accept them. I don't accept them on theoretical basis. But I think they just happen to give the right result, because if you, and we can prove this actually, if you take a total time derivative, a convective derivative in the general Maxwell equations, you will find that you get, and you use Galilean transforms, you effectively get a quasi-Lorentz transformation. So they work in practice. This is one of my objections to Stephan's paper. I don't think the Solari transforms actually work in practice in giving these transformations correctly.
Well, yeah, that's kind of another subject. To answer Jim's question, there are a number of books out there. If you go on the internet and if you search for a relativity in engineering or relativist applications of relativity in engineering, you'll get. I think you'll get. I have a copy of a book here where he goes into engineering applications. There's a number of books where they talk about this, but it's kind of esoteric stuff. I mean, it's not something like you're going to use relativity to design a refrigerator or a TV set. I mean,
Okay, fair enough.
But just one more thing. Even sort of elementary third level physics books, they would show that you can derive the expressions of classical electrodynamics, which have been shown to be in accord with experiment by using relativistic means or by using Lorentz transforms. You can actually do that.
Yes, I understand that. I don't have a real problem. I don't have a problem with the LTs themselves. I think the problem with the LTs is that they're not really understood what they do. And I think what they do is they transform the basis of measurement. They don't really change time or space. And then you can look at it from the point of view of they transform electric field, magnetic fields into electric fields. That kind of makes sense, but you can't go backwards. You're kind of stuck there because you've got the paradoxical nature of the LTs. So.
Well, that's an interesting point, Harry. But I must confess, I just consider the LTs a mathematical trick. There's nothing really fundamental or physical about them. That's the way I look at it. It's just a mathematical trick which helps you if you haven't taken these total derivatives into account.
So there really is some agreement in general terms, at least with my concern. Thank you.
Okay.
Well, I mean, I'm not really sure what that, you know, as an engineer, we use mathematical tricks all the time to design things.
I have a suggestion. After this talk for half an hour, you must, Harry, to give presentation about these issues we talked today about. Because Stephan, he must not be the winner of the whole society. There are so many experts in our society, and we took his report as it is. No, it should be answer of it. Show how it should be, how it must be. What is the correlation between this and that? Whatever I thought today, it's much more convincing me than what I thought yesterday. It must be, Harry, no doubts about it. We cannot keep silence. Forget it.
Well, like I said, I'm not sure what to say about that. I think from Ian's point of view, you know, having Stephen, the purpose of the CNPS or whatever, one of the objectives is to have people to present their ideas, even if they're wrong.
Yeah, but you should give some, corrections, or should your response about what is right, what is wrong, and so on and so on. Because people like myself confused who is right, who is wrong. That's why I want to hear the right way to explain it.
Yeah, I understand this.
Well, the very fact that we've spent one of the 3 sessions today just, rehearsing it or giving our response to what happened yesterday, to me, that justifies yesterday. And if we spend the next 2 sessions dealing with Harry's work next week, that's very valuable as well. I'm not sorry for having
I understand your point.
Yes.
The issue that